G'day everybody and welcome back to the channel. I thought I'd get started on a couple of other little projects. Well, not a couple. I've got my power supply that I'm currently building and designing. I've got this old Motorola CB radio power supply. And what I want to do with it, basically change a few things on here, but I want to keep it's basically just a 2 transistor Zener regulator with a driver and 2 like 3855s, or what are they, 9639, no, they're 185 transistors. Sorry, I was looking at the wrong number. So there's a couple 185s on the back. Now all I wanted to do to this, I was going to take this capacitor out, this one too. Not just, I'm going to recap the whole thing, but I'm not doing it because the caps are no good. I'm pretty sure they're perfectly fine. These, especially this nice old Sprague 1400 mic at 40 volts, that'll be kept for something else. I can guarantee you that. That's a beautiful cap. No, the reason I want the caps out is I want more capacitance because I'm going to make a power supply out of this. So I want extra smoothing and ripple, and it's going to run at a higher voltage than the 14.8 volts it used to put out. I've measured this transformer. There's like 40-50 volts on it, so we can do things with this. I mean, obviously with drop and after filtering off ripple and all that, there's not going to be that much, but it's still not going to be 14.8 volts. So that's it. I've really done nothing more than what you can see here. I'm just going to take a seat. I've literally drilled a hole in the front, started drilling a hole because I was going to mount something there. It won't make sense to me until I put this back in. Okay, because there's space in the front here, even with this cap there, I decided I wanted to start mounting pots as close to the board as I could going this way, and if that makes sense, because what I want to do to this, adjust whatever values I have to the circuit that's on the board, say the Zener diode value, the value of the pots and resistors, stuff like that. I've got to reverse engineer the circuit first because I can already tell you from looking at it now, I see 2 transistors up here which could just be Darlingtoned up with this driver for the output, or it could be more complicated than that. But I do see 2 transistors over here that look like they're hooked up as a comparator and a series pass element for that Zener there. So I imagine it's a 2 transistor Zener regulator with adjustable feedback, Darlington driver, output on the back. But I could be wrong. I've got to reverse engineer it and we'll know. But whatever it is, I'm going to make a few small modifications to the circuit. The reason there's solder on the fuse socket, a long time ago I was using this just as a 14.8 volt DC supply, but I would pull too much amps from it and the transformer would get very hot. It was already all old and melty looking like this. It's not actually melted, it's just how they look. These transformers run hot at idle anyway. Now, what I ended up doing, instead of putting a smaller fuse in there and then blowing the fuse all the time, I put a circuit breaker in there, and I just had a little circuit, like a 6 amp or 5 amp resettable breaker soldered across the fuse socket. That's all that was. Anyway, so I guess the first thing to do, sorry, let me just finish telling you what I want to do. So reverse engineer this circuit, or either reuse this board and just modify values, or I'll make up a whole new board for it. Either one suits me. I'm really not fussed. Reuse as much stuff as possible, you know. So if I reuse the board, I'm going to reuse the connectors, the original cables. You know, I'll even reuse the original power LED. I'll keep it as original as I can. But what I want to do is I want to add a voltage pot in the front. Now, it doesn't have to go down to 0 volts. This is not a special supply with, you know, the craziest ripple and noise rejection and high accuracy by any means at all. This is just going to be your average adjustable power supply, just with fold back current limiting. So no precision current limiting, just a single transistor and a resistor, you know, in series with the series pass emitter, and yeah, and a pot. You know what I'm talking about, a fold-back current limiter. So nothing special, right? That's all this is going to be, and just a dodgy-ass panel meter. I want a switch on the front, and I want a ground post. Because the way this was built, as you can see, it's just permanently grounded. So I want the option to bring ground out to the front. So the first thing for me to do here is going to be give it power and start taking measurements, because I cannot remember what voltages we've got to work with. And that's the first place to start. I obviously need to reverse engineer the schematic, but the first thing I need to do is I need to find out what voltages I've actually got. Okay, so that's the output connector. I don't need that. Alright, and I need to get into the back. Now, I might end up putting a fatter bridge rectifier in here. The reason for this, with regulator circuits, I need to put a new plug on this too, because when I was using it as a power supply, because the earth's permanently connected through, I did this dodgy shit. Yes, when I was younger, I did dodgy shit. I think you could probably tell by how old that looks. I did this quite a few years ago. Honestly, not not too long ago. Whoops. Oh, well, that was dodgy anyway. Who cares? But I just did that so I could disconnect the earth on it when I didn't want to earth. I know, not the safest thing to do. I mean, it's fine for me. It's fine if you know what you're doing. But I mean, the problem with doing stuff like this is when it gets into someone else's hands and they don't understand what they're doing. That's the problem, really. So, yeah, fine for me, but still a dumb idea. Anyway, as I was saying, with regulator circuits, if they have high gain, lots of feedback, op amps, stable references, stuff like that, they'll tolerate a lot more line voltage variation, or input voltage variation, should I say. But a regulator with less gain in its drive and series pass elements and in its comparator, and a regulator with a voltage reference that's not as accurate and heavily relies on the rail voltage for its accuracy, what you'll find is the bigger bridge rectifier you put in there, the better regulation you'll get on the output. Because what happens is, as you draw currents and the amps go up, the VF on the bridge goes up, forward voltage drop. It goes up. And because the regulator circuit is relying on the reference from the Zener diode and the gain of the comparator and the gain of the series pass elements in a closed feedback loop, as the voltage forward voltage drop increases on the diode and the transformer voltage sags, your Zener voltage, your reference, starts going down, your comparator starts losing voltage, and the regulation gets worse and worse and worse. The stiffer you can make your rails, so number one thing, bigger rectifier. That's the number one thing. Obviously, the more closer to saturation your transformer's running and the thicker its windings, blah, 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 yes, that's going to help too. But I'm not rewinding the transformer. So the best thing you can do is put a bigger rectifier in there. The second best thing you can do is add a shit ton of bulk capacitance. But remember, bulk capacitance will only help you smooth ripple and noise, and it will only help with, well, for your device, inrush current, but from this thing's point of view, outrush current, right? It's not going to help you produce continuously more power. I don't know why there's this whole thing I see, especially in the audio field, about people thinking that if they put more capacitors on something, they're going to get more power. That is not the case. In some instances, due to, say, resistance of cabling or internal cell resistance of a battery or an alternator or something like that, or a power supply's ability because of the resistance of the windings, diodes and output, stuff like that, or a switch mode power supply's feedback response time. For reasons like that, capacitors are handy because, especially in audio and circuits that require peak inrush current, because like those things I just mentioned have problems dishing peak inrush current out, but they can supply the continuous current. They just have a problem supplying that initial pulse quick. So capacitors help out with that. But that's the thing, you know, if you got a solid transformer, a really good stout rec, and a solid cap bank, the three things go together, and your regulator will have a lot better regulation of that than, say, a high impedance transformer, a small rectifier, and a shitty little cap bank with, you know, a lower capacitance value and a high ESR. Anyway, enough on basic regulator theory, but it's always good to do different things. Like I'm currently working on a really complicated ass build of a power supply, and I thought I'd mix it up because I've got space in here for multiple projects. So I've got the Yamaha mixer in a little shelf on the floor to the left of me. I've got my power supply I'm working on at the moment on the shelf behind me, and this also fits on the same shelf. That's right, that's where this has just come from. So the beauty of it is I can do a bit of work on this if I run out of parts, which I shouldn't in here, or more likely enthusiasm, because I've got a short attention span. Well, then I might, actually, I'm going to take some measurements first. I might end up putting this back on the shelf and then going back to something else, but we'll see how we go. All right, so I'm going to power this up. I've got the earth disconnected. The reason for this is I want to measure phantom voltage and stuff like this. The reason I've decided to keep this power supply for building a little power supply is, although it's not going to be very accurate, it is going to be bloody good at common mode rejection and noise and ripple. I don't know if you see this, but that's an earth wire. This little piece of metal here, that's also earth. This band is earth. This black wire is earth. Those of you that do electronics know where I'm going with this. Those that don't, I'll explain it. I just want to put that out there so no one thinks I'm trying to be a cocky cunt. Oh shit, I shouldn't have said that word. I guess one or two of my videos will get demonetized when my channel eventually gets monetized, but something I'm just going to have to be more conscious of, eh? Anyway, when I'm a cocky one, that's not what I'm trying to say. I'm not trying to be cocky. I'm just trying to explain it for the people who don't know and not be cocky to the people who do know. This thing was designed for CB radios, and this transformer is made, how do I say it? It's puts out a way higher voltage. It's really well shielded. That way you can filter off a lot of ripple rejection and shield the EMI from it. It's also grounded, so you can shunt your common mode noise. They took everything into consideration on this, so it makes a good candidate for making a power supply. Now, there's not a lot of space in here, so it's not like I can really make a high accuracy power supply. I mean, I could if I went SMD, but I don't do SMD. I do if I have to, but I hate it. So, anyway, enough talking. I'm going to get to measuring. That's on. I remember that there were spicy voltages in here. I just don't remember what they were. And when I say spicy, I mean like 40, 50. I'm just saying for a 14 volt supply, it's pretty good. I mean, it's got potential. So on the output, we should have our regulated 14.8. What? There is nothing wrong with this supply. The last time I used this, it worked and the power light's on. If I had a dumbass Dave moment and turned the pot down in it and turns the regulation all the way down, I wouldn't be surprised, because as you can see, it's on. And yes, it's a Motorola too, so there's a lot of reasons why I decided to keep this thing. And you can see the ratings on the bottom of it, 13.6 volts, 8 amps. So it's, you know, it's a good candidate for building a power supply. Oh, 8 amps, not 6 amps, there you go. But in experience, I pulled 5 amps out of it and the transformer seemed to run very hot, so I don't know. But we'll work all this out as we come to it. What's on the output when it's plugged in? Oh, what? I mustn't have just been measuring between the right spot. Well, obviously. Alright, so let's see what that voltage adjust pot does. Because like I said, I'm not going to change anything in here that I don't have to change. Like that. And don't worry, I've owned this thing for a while. All the capacitors in here are voltage rated for like well above 35 to 40 volts, most of them. All of them, should I say. And the transformers are all like 45, 50, 65 at least volts. So there's no problems with turning voltage up or down on this. So we can just go all the way. Let's see how low it can go. So it'll go down to 7.56 the way it is. And it will go all the way up to 24. You know, I'd be happy with that, 24, because off memory, the main rail in it was pretty big. There you go. Oh no, 24. Wait, is it? The output. That can't be the output capacitor, no way. Surely not. No. Wait, if there's only 24 volts there, we can't turn the output up to 24 because it's going to be no ripple rejection. There's only 24 coming in. 23.64. You know, let's do some reverse engineering. I got a funny feeling that this transformer winding's in series, or I don't know what's going on. I'm going to have a look at this. You'll see what I'm saying in a second. Just need to get some more access. No, there's only 2 wires that come out the transformer. And 2 that come back from the bridge rectifier. And these other wires should be, yeah, base and emitter. Okay. So that can stay as it is. Let's see what voltage the Zener diode is in here. When you're designing a single or dual transistor comparator with a Zener diode, you want to keep your reference voltage, I think it's between 1/4 and 1/2 of the output voltage. Let me just get my DC handbook, design power book from Agilent from back in the day up. I've got so many publications on this PC, it's absolutely amazing. And I've got military docs, all sorts of stuff. I'll actually pause the video, I'll get a couple up and I'll show you because it's quite interesting. Alright, I can't find the document that I was trying to find, but from memory, because like when I design a supply, I design it with an adjustable reference so that it's accurate the whole way through. But if you have a fixed reference and adjust the feedback, I'm pretty sure the reference needs to be 1/4 of the full output voltage to 1/2 of the full output voltage to maintain the best regulation. I think. Don't quote me on that, but I'm pretty sure. The reason I say this is because I don't know. It just rings a bell for a few different reasons, actually. But yeah, anyway, so next thing I want to see, what is the voltage that we actually have to work with here? Don't worry, I'm not jamming these all the way in and splaying the pins out. I'm just holding them there. I have to flick my meter over when I turn this on because it's on DC still. Because I'm a dummy sometimes. Wait, what am I saying? This is after the rectifier. Okay, I'm clearly not in the right spot. What? Oh, and you guys can't see this. It's just very hard to not short everything whilst doing this at the same time. So what colour comes from the transformer? Brown. So we must be looking at orange and grey. $35? No, I swear there was more than that. Let's just... Okay, that's obviously not the right side. Well, what? Are they doing some sort of funny rectification, like halfway? What's going on here? Hold on. There's AC in there. That is AC in there. No, that is all it has. And then rectified, you got your 24. Okay, so this doesn't actually make as much power as what I thought it did. So maybe we'll get 0 to 15 volts at 5 amps or something like that. I don't know. All we can really do... You know what? That's a good point. Let's put this back in just very bodily, just for now. Let's see what we can get out of it. Hello, little man. Hey. Little man, they're kittens. Alright, just before I put the camera in the tripod, I'm just going to show you. I've got the load bank, alright, going to the output. I've turned the voltage back down a bit. The load bank reads a bit high. It's actually 18.15, 18.2 now, something like that. It was about 18.35.4 before. A little bit over to allow for sag, but not too much over because I want to see what it's like at 18 volts. I've got my scope hooked up to the output capacitor off the bridge rectifier, not the output off the regulator itself. And I've got my multimeter looking at the transformer's voltage on the capacitor. Again, from the bridge rectifier, not the output. So what I'm going to do is sorry, that swamps out and you can't really see it. I do realise this. Unfortunately, unless I can change the brightness or something, I don't know what I can do about that. But I guess it doesn't matter. I'll just leave this menu turned on and cycle through whilst it's turned on because you can see the amps on the screen. So like if I leave it turned on and go into this menu and hit up 1, you'll see it's pulling 0.1 amp. If I go across and hit up 1, you'll see 1 amp. So that works. Alright, so that's what we'll do. So 24 volts. Oh, and you know what might help? Setting the scope to appropriate time base, voltage, AC coupling, all that sort of thing. Wait, is this thing halfway rectified? I'm gonna have to look at this. Something is a bit weird about that. Oh, I was clipping. I'm a dumbass sometimes, aren't I? No, that's... Okay, I can do a better job on this. Alright, well still let's have a look at how that increases and how this decreases compared to load. So 1 amp, we lose a volt, and wow. Jeepers cripers. I'll just go up to 2 amps. Okay. 3 amps, 4 amps, 5 amps, 6 amps, 7 amps, 8 amps. Okay, well that's actually, considering that's only, we dropped down to 19 volts. So 8 amps. I want a few volts. There you go, at 6 amps. So you can see that. That's 100 watts, 104 watts. I've got 19, 20 volts on my input cap. 17, 18, 24 volts headroom. Yeah, that should be enough for ripple rejection. And I've only got 800 millivolts and 2.86 volts peak to peak on the mere 1400 microfarad input can. So, alright, we know what we're going to get out this now. It's going to be something to 18 volts at 6 amps. So, let's take some notes. So this is the fun thing about my channel, is what I'm doing with this channel is there's going to be repairs, there's going to be builds, but when I do builds, you'll see the whole engineering process. So it'll be quite interesting for people that are into that sort of thing, including stuff like this where we're modifying something. So 18 volts, 6 amps. That's the goal we're shooting for. We might not get there. We might fall a little bit short, like 17.5 or 18 at 5.5 amps. It just depends on the results at the end, how much noise we got in the output. I'll leave that open actually, and I'll just leave that on my bench here for notes. Alright, I'll pause the video and I'll reset up again. Alright, back at the bench. I'm just going to unplug. Alright. Whoops. So, next thing I'm going to do is I'm going to measure the voltage of this Zener diode in here. Alright. Instead of unplugging, I'll leave it plugged into my variac, and I'll just use the switch to turn it on and off. It's only plugged into the variac because I've run out of power points, if you're wondering. 6.5 volts. That makes sense. That's about a third of what it was putting out. No, close to half of what it was putting out. Like I said, you want at least a quarter to a half voltage on the Zener. So that makes sense. To get it to go down a little bit lower, I could put a 5.1 in there. I wouldn't go lower than that at the risk of sacrificing regulation. Could also put a TL431 in there. Yeah, I don't really want to put too much into this thing, but I'm kind of happy how it is. I think what we'll do is we'll just start reverse engineering and we'll go from there. Which means let's unplug it and start pulling it down. There are a couple of oddities in here that I wanted to change. So like I said, I think I might just leave the bridge rectifier. I'm not too worried. I thought the ripple was going to keep getting bigger and bigger and bigger, but it only got up to that certain point and sort of stayed there. One of these is a 3% resistor. One of them's a 10% resistor. One's 7 watts, one's 8 watts. Both 0.1 ohms, but I'll, just for the sake of it, I'll change them. It's not going to electrically make any difference, but the thing is, I'll use the 0.1 ohm 3% resistor in a high tolerance situation in one of my projects, and that 7 watt resistor to me looks more like, I don't know, I guess it is in between a 5 and a 10, so yeah, it's probably about 7. But yeah, I'm not going to touch anything in the back. I'm just going to change those 2 resistors. Transformer's staying where it is. Everything's going to happen on the front panel and this board. So to start off with, I want to remove this earth wire from the negative of this capacitor. I want to remove the LED and the capacitor. What a beautiful capacitor. Sprague, Powerlytic, 14,000, microfarad. Oh, I'm not changing that. I thought that was only 1400. Wow, this thing's output must be real smooth. Let's see what the ESR is on this, if I can even read it with my ESR meter. I doubt I can. The capacitance is just too high, but I think at some frequency ranges it's alright. I can't remember what. We'll see about that. I'm just seeing if I can trick it into working somehow. No chance in hell it's going to read something that big. Alright. You know, that's not a good sign. I can tell you from experience, when this has got weight to it, it can't have dried out. I don't know quite what to make of this. My meter can only set up to 10,000. Okay, that's fine. Once I got it to charge it by falling the meter and shorting it, yeah, Okay, so that cap's good. That's 1400 microfarads. I'm going to keep that in there. That's not getting changed. Keep that driver transistor too. I'll just go get a 5.1 volt Zener. I wonder what all the capacitors in here are like. Well, I'm honestly going to say I'm not touching nothing in here. These are all Nichicon capacitors. Every single one and a Sprague. And they're all coming in beautiful. I'm just having a quick look at the schematic. I don't think I'm going to bother drawing this out. I can pretty well see what's going on here. Yeah, this thing was already designed to be quite quiet. Yeah. I think I'm just going to add fold back current limiting to it and bring the pot out to the front. If I got space in here, it's a bit tight. I might not be able to fit current limiting because I want to add a pot, banana jacks and the panel meter to the front. We'll see how we go. Either way, I want to at least adjustable voltage, and a voltage readout on it. Alright, well I'll put this back on there. Actually, I'll change the Zener first because that's going to be a lot easier to do. God, what sort of soldering is that? Let me just think about something. What's a quarter of... Wow, there's been a big arc there. I wonder what happened to it. I never did that. Only thing I ever did was change a fuse to a circuit breaker on this. Anyway, I'm just trying to think. 5, 10, 15, 5.1. Yeah, that's already less. Alright. I'll get a 5.1 volt Zener. I'll be back in a moment. Alright, I got the 5.1 volt Zener. I think I am going to reverse engineer this just quickly. You know, I might want to change capacitor values, transistors, anything. I don't know. I'm just going to give it a quick reverse engineer onto a piece of paper and I'll come back and show you the circuit. I'm just in the process of making up whoops. Making up some new what do you call it? Terminating a fuse holder. I'm just going to stop the video. I've got to go get some wire. was recording some video before and I made a right mess of everything. I soldered this wire back down here, and then I took the active wire off and pulled it out over here, went to run the switch, and I realised, you dummy, I'm running the switch from the fuse to the transformer, not from the active to the fuse. So I just deleted that bit of footage, but like I said, I'll always keep true to what I said in the channel. I don't edit my videos, and if I am going to edit something out, I'll tell you what I did wrong. I just hate those people that act like they're perfect and do everything bloody right, you know? Like, no, I know that these other people in the electronics community that have all these perfect videos spend hours and hours of time editing and removing. I'm not stupid. I've been doing this for a long time, you know? And it honestly annoys me, you know? And I'm not talking about, you know, like people who, people like Marco Reps or Michael Dranfield, and, you know, people who have really been doing it for a long bloody time, or are really, really into it, or Signal Path, you know. But I'm talking about people that aren't at that sort of experience level, but they still try and make out that, you know, everything works. They don't ever show failed repair attempts and their screw ups and all that sort of stuff, and they act like, you know, it's all, I can't think of the saying, but you know the point I'm trying to get at. Oh no, the heat shrink. I thought I left my heat shrink off. Anyway, that gets to me, so I try not to edit my videos like that, and if I do something wrong, I'll point it out, or I'll just leave it on the camera. I'm gonna have to go back before that starts to shrink, because I mangled the end of the end of it up. Little stretchy. The reason that didn't go down successfully is because I tried to put it down whilst the end was still too hot, and I should have waited for it to cool down. Sorry. It's a bit hard to get in here. Also, when you're using a heat gun, you're trying to aim at what you're aiming at, whilst not melting everything else in the vicinity, so it can be a bit tricky. So my apologies for bumping the camera. Actually, I might just move it a bit that way. Yeah, that's good. I like that. That way I can get to what I'm working on, and it's got a good permanent position. So before anyone worries about this being auto marine cable, yeah, it's PVC insulated. Yes, I've checked the insulation. It's at least 300 volt rated, so don't worry about it. It's not going to break down at some stupid low voltage. And it's also 7.5 amp cable, if you're wondering, which will be plenty fine for this, because one, we don't need best voltage regulation, so it doesn't matter if we drop a little bit of voltage on the cable. Two, it's going to be a 5 or 6 amp power supply, and the length of the wire is only going to be like yay long, so yeah. I'm talking about on the output side. Haven't thought about where I want my switch to go. Considering that big capacitor is staying in there, I might as well just leave that there for now, because that, I know I've got a board here, so I can just visualize basically this hole and down and this space. I know that I've got it, and I know that there's a power transistor that, it sits there too. So sort of this box here, I've got space. So I've got my output jack there, my power indicator there, but I want to put constant current, constant voltage, or fold back current and fairly constant voltage. It is technically constant voltage because it's not just a Zener regulator with no feedback. it's got feedback, so you know, it's just constant voltage with poor regulation. But anyway, why did I drill that other hole for? I can't remember. Oh, that's so annoying. Oh, I remember why that's there. Because a long time ago, when I was using this for something else, and I had soldered a circuit breaker across there, I just stuffed a whole load of tape around the wires and drilled a hole in the front and stuffed the circuit breaker out the front. Forgot about that. Can I utilise that hole for something? Also, what can I do about this? Maybe I can put my power switch here. Because obviously I'm not using this no more. Let's see. What? Ah. I was going to say, this was almost like it wasn't removable, but you can see that it clips in. But as you can see, the clips are there, so from the front, if you try and push it down, you can't. The whole plug just moves down. You've got to go from the back. It's a really obvious clip once you can see it. Now, that LED was running off 24 volts, so I know the dropper resistor that's in here is for 24 volts. So I'm going to leave that there, because this I'll probably just put back on the same location. So I'll just put these wires in this little gap here for now, so that they're not getting moved around and I don't break the LED. Let's see if we can fit our power switch in here. I don't care if it looks a bit janky. Yeah, it's going to have a little bit of gap that way, but I can just cut it longer and make use of that hole. Let's face it, I'm not going to be able to put anything else in there. I could put the panel meter down there, but I don't want the panel meter down the bottom. I was going to probably start with this hole here and cut out the rest of the square, rectangle, sorry, for the panel meter to get rid of that hole. So I think, let me just get this tool I've got, a nibbling tool. I'm not sure if it's going to be able to cut through this thick of steel, but I'll give it a go. Just don't want to ruin the tool. I guess I can get another one. Yeah, they only come from J-Car. It's not like it's the end of the world. I am going to go through all the rest of the holes off camera. The only reason I'm doing this part on camera is because I'm wiring the power switch up to the fuse hole, and I wanted to get all that. Damn, I can't get this one bit. Got it. I wanted to get all that on camera for you guys, so. Ow. One more should have it. Should be it. So I've just made the bottom a bit bigger, just enough. Oh, that's bloody perfect. Cool. Which way do I want it? Yeah, I want it that way. Can't complain. Happy with that. Alright, let's route our wiring to the power switch. Now, this is something you guys probably already gotten used to with me. My mind jumps backwards and forwards. It's because I have got autism, Asperger's, and ADHD. I was thinking about this two-stage capacitor filter. I'm going to get the schematic diagram for this because I can't be bothered reverse engineering it. I can already see most of it with my own eyes. It's very simple, but I might add a few improvements to this. So I might add capacitors, change their values. I might change one or two transistors for a different type. And I might add some resistance in between the two-stage capacitor filter so it has more ripple rejection. You know, just a few little things like that. So I'll get the schematic for this and we'll have a look at that afterwards. But I am going to keep the board as it is. I might just change a few values of things to make it better. Okay. The beautiful thing, it's got this plastic grommet around the metal, so you can just run all your wires straight through and not have to worry about them rubbing out on anything at all. Brilliant. This is why I like older stuff. This is a 1970s, 1980s power supply. I'd say 80s. And, you know, look at the way it's built. And not only that, it still works, and it's getting a new lease of life as another product or an improved version of itself, still with most of its original circuitry. This is why I'm always boasting, bragging, whatever you want to call it, about old electronics just being the way to go. All this new stuff's just bloody rubbish. You know what, I will put some heat shrink around this too. I can get it on from the other end, don't worry. Don't worry if I drop solder balls and stuff in here. I know I've already done that, and bits of wire stripping. Whenever I work on something, I always end up tipping it upside down afterwards and shaking it around to get everything out first. I see a lot of people, again, repair stuff on YouTube, and I literally actively spot them dropping stuff inside and they don't notice. And they put the cover back on, and I'm sitting there going, God, I hope that fell out on the floor. Just had to get a bit of solder off the metal and onto the cold area so I could pick it up. Oh, and I got a bit of wire stripping with it. There you go. Alright, back to this hole. Hole's clear. Just going to strip that just a tad more. I'm not worried about heat shrinking that wire. It's got like literally over 1 centimetre of clearance around it. And these other wires are almost solid core, they're that stiff, so I'm not really worried about them rubbing out on it. Oh yeah, that's why they weren't worried about them being close to it in the first place, because they had heat shrink around it. Fair enough. But the thing is, once this very solid pin is back over there, that has got so much clearance between it and other things. You see what I mean? I'm not worried about it. I do have a huge piece of heat shrink. I just realised I could have put something over. Oh well, too late now. I'm not going back again. Hello, little man. Hello, little man. Yes, this is YouTube. Oh, you love your cuddles, don't you? Oh, one of the other kittens is in here today. Yeah. Hello. I've got to get back to work. Sorry, guys. Right. Sorry, little man. He's busy. Oh, how did I get that through there? Damn. I didn't mean to do that. That's honestly kind of funny. What is that? Oh, man, that's annoying. I really didn't mean to do that. I didn't even see that. I wonder if these come out easy without damaging the connector. Hey, no, get down, you too, hey, thank you. Cats. Hey, no. I don't know what little man's problem is with the kittens. Yeah, it'll be alright. Luckily, this is just coming off the bridge rectifier before the smoothing cap. Oh, we've got our base and collector lines here too. That's alright. The wire's basically going across it. There's not going to be any crosstalk. It's fine. Yes, I'm that fussy. I don't want AC hum getting capacitively coupled in because wires are all strapped together. Can you get down? Seriously? Down. Thank you. No, down. Down. Come on, I'm busy. Down. Thank you. If you're wondering why I'm running all the wires fairly tight, it's because don't forget when the case closes up, there's extra slack. So it actually works out just perfect. Getting some heat shrink now. Because this wire is going to be floating in the breeze, what I'm going to do is I'm going to double insulate it. So 2 layers of heat shrink. It's not necessary, but solder can sort of poke through heat shrink, especially if it's being rubbed on. So it can be a good idea. Solid core cable. Don't worry, that is plenty strong. It's leaded solder, and I know how to solder. Yeah, you should twist the wires together and all that, but trust me, that's not going nowhere ever. I wouldn't say the same for lead-free solder. That stuff is crap. But when you saw all the solder inside that power supply that I rebuilt, that old power supply, right? How old's that thing? That thing is from the early 70s. And solder was beautiful in it. There's not even signs of a dry joint starting. So, you know, leaded solder. Can't beat it. 60-40 all the way, baby. Alright, so now we've got our switched power. And the other thing I want to do in the back here is these resistors. Just give me 1 minute. Alright, so I've tidied up the wires in here just a little bit. We're just going to tin up this earth wire and run it to the front ready for the earth connection. That's just going to get globbed up onto this. just like that. That'll do for me. That is flowed through all the way, and there's a huge ball on the top of it to make up for what flowed down. That's never going anywhere. And that's my earth. I'm fairly happy with that. It's good enough for me. I'm just going to leave those resistors in there. Who cares? They're 0.1 ohm. It's not like they're ever going to dissipate the wattage that they're rated for. So there's no problems with wattage wise. I just wanted to keep the 3% one, but I've got a few high tolerance shunt resistors anyway. I left this a little bit extra long because I'm not sure where my jacks are going to go yet. So that's just like that. I'll screw this back on so it's not flopping around in the breeze anymore, because there's no more work to be done in the back. I don't think this thing's designed to dissipate its rated current all the time, both the transformer and the heatsink. So this might end up getting a little hole cut above the transformer and a fan mounted and some holes drilled in the bottom of the case, and might end up with a different heatsink or a fan on the back of that heatsink somehow. I don't know. Well, I guess I probably wouldn't even do that. I'd probably just derate the current on it, to tell you the truth. Well, it's all worked out nicely. Yeah, I'd probably just derate the current on it or something. I don't know. Haven't thought about it. We'll cross that bridge when it comes to it, if it comes to it. Alright, well so far I'm happy with that. That's all come out fairly neat. Could have been better, but it's fine for me. I've got no complaints. So I'm going to stop the video here, and I'm going to get the schematic up for this board. Do I even need to bother? Let's just use our brains here. We've got 200 ohm resistor coming in to the positive side of this capacitor. Wait a minute. Wait, what? Oh. I'll just get the schematic for this. I might want to make a few changes to it. It's not laid out exactly how I thought it was. So I'll get the schematic for this and I'll be back. Also, if anyone's wondering, just, some people are curious, like myself, the transistors that this has on it are Motorola 9649 9642, 9706, 9648, and the driver transistors are 2955, MJ2955T, and the output transistors are 185s. Alright, I'll be back shortly. I swear to God, everything I go to do ends up being more complicated than what it had to be in the first place. So I was looking at the connector here going, okay, positive, negative, collector 1, collector 2, base 1, base 2, right? No. Look at this. One wire goes to the output, the other wire goes to this, the other wire goes to ground, the other wire goes to, I don't know. So now I've got to take the backpack off because these aren't just how I thought they were, I don't think now. Unless there's just extra wires for feedback and they're taking feedback from all the way at the back instead of the front, in which case I'll be changing that and moving the feedback wire to, you know, like the remote sense, whatever you want to call it, sense wire. That will be going to the front panel. Let's see. I had a look for schematics and I could find every Motorola bloody power supply, TPN versions and everything except for the bloody ACN series, which is what this is. My luck. Alright, so one of these wires is positive. Wait. Sorry. One of these wires no, you gotta be kidding me. No way. I'm going to make some modifications in here. I didn't see it. There's no base resistors. I want base resistors. This is not the layout I thought it was. So we've got our collector power here. That's obvious. Is that positive? Yep, that's positive. They're NPNs. Well, it doesn't necessarily mean they're NPNs. Let me just find out what these transistors are. I don't have the data sheet yet. I guess the quickest way to do it would just be to do this. You silly tester. Well, since I'm adding base resistors, let's remove the base wire. Far out. If I'm going this far, because it's not the layout I thought it was, I might end up redoing these resistors and just redoing the whole thing. Might even spin my own board too. Well, I didn't mean to melt that, but I did. It's not the end of the world. As long as there's no bits of solder that are not part of the blob of solder that are just sitting on the plastic, waiting to fall off into the supply at some time. It's all good. Okay. Got my base feed. Now, you see we're bringing our collector straight over here to get our positive to the board, okay. Why do we have a wire coming off the emitter going back to the board? Just plug this in so I can see what wire that is. Yeah, idiots. They're doing the feedback off of that point. Wow. 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 Okay, well, I'll probably still just leave those resistors in there. I'll just cut this wire off. I'll add base resistors, but I'll leave the emitter resistors. Alright, we've got our output wire off the resistors. That's how I want it. So now everything in there is kosher. Now, there's also a second wire that comes off the AC that goes back up to the plug. What? Okay, I'm respinning this board. Wow, this is not as good as what I thought it was. It's actually some sort of weird half-wave rectified output. That sucks. That's okay. Now we get to do a two-part video where I get to etch up a board. And we've got some design to do. If you ask me, that's cool. Okay, so I don't want this here either. I know a lot of people are probably watching this just horrified, going, what on earth are you doing? Don't worry, don't worry. I know the rest of everyone who does electronics wouldn't be thinking that. I don't like the way that can almost touch the case. Just gonna do that. That's got enough clearance. I guess it can't really like that. That's fine. The more twisted it is, yeah, perfect. That metal can't touch the case. All right. Basically happy with that now. For what I want in the back end of it. Yeah. Hold on, someone's at my front door. Alright, my apologies. No, get down. I've got your phone. What is going on here? This is really not good. I I am bloody confused. Well, you guys can't see the tester. I've got 2 diodes. You see, everything on this end of the connector is open, so yeah. What? What is it, that low gain that the tester can't tell it's a transistor? I could see that happening. I shall ask the DCA Pro for its opinion. What? What? I'm sorry, but what? I have to be missing something. What path does it have back anywhere? What? Oh my god, I'm baffled. I'm absolutely baffled. Wait, is one of these transistors buggered? How is this working? Really? Wouldn't that resistor be up? I'm just going to pull these transistors. Most likely just going to stick a couple of 3055s in here. But I'm not liking that. I'll do this off camera because I've got to undo these screws. But I'll take them out and then we'll test them and put the new ones in on camera. This will be a multi-part video obviously because I'm going to spin a new board. And there's a bit of work going on here, so. Hey, at least it'll end up with a fallback current limiting because I was umming and ahhing on adding it with how big and chunky all this was, but yeah, all good. It'll fit. Alright, I'll be back. Alright, so the transistors are out and I've just cleaned that surface up. I've still got to clean up the mica insulators and I've lost my screwdriver. Oh, that's right. I'm using my drill. I'm not used to having a drill because it was broken for so long. Let's see what the DCA Pro has disappeared. There it is. What the DCA Pro has got to say with these completely out, because maybe I was missing something with, oh no, this thing is built a little bit weird. Anyway, what I'm planning on doing with the new build is repurposing still every single part that I can out of this thing. So, yeah, rectifier, transistors if they're good, all the normal small signal transistors, the driver and its heatsink, capacitor, everything. I'll repurpose everything that I can reuse in my build in this. Oh. Now I'm really confused. These weren't hooked up. No, they are. What? Wait, I'm an idiot, aren't I? Did I just test? I just tested my new ones, didn't I? Not paying attention to what I'm doing. Or did I test these? No, it was these. Base, blues, emitter, green was collector, yeah, that's how they're wired up. What? Everything's open. How? When they're in the sockets, the only two pins that connected together are the collectors and the emitters. They should both be reading the same, shouldn't they? Everything else is open. I'm bloody confused for a minute. Hold on. I'm gonna have to clean these up. I'll go clean all this up off camera. I'll come back. It looks like the original transistors are going back in. Well, let me just test this other one because I'm an idiot. I don't know if I just tested the new ones or both the old ones. So let me just double check. These are fine. Okay, well, I don't need to put these, they're only CDILs, 2N3A55s in there. We can keep the original transistors, that's good. I was thinking maybe they were hooked up in some sort of strange configuration, but it doesn't even seem that that's what's going on. I'll pause the video, I'll clean all this up, and we'll come back and continue. Alright. Just make sure the legs are straight, because they're not. That's better. Try and get the pins in the pin sockets this time. Okay, much better. I know it looks like there's not much heatsink compound, but if you press it down, it all spreads out everywhere. There's actually a bit in there. No, that's not gone in. Wait. Why are they springy? Oh, I see. You've got to hold the back plate as you put them in. No, that's not going in. One of the pins is trying to go down the side of the pin socket, not in the pin socket. You know what? I've bloody changed heaps of these and I've never had a socket this fiddly. Okay, I take it back. It's because the pin was bent. I might have been a bit rough pulling it out. That was my bad. I was going to say, these are the most fiddly sockets, but I've never had trouble. Yeah. That's what I'm used to. Alright. Now I'm going to do the screws back up on these because obviously something's up circuitry wise and that's what was causing that issue. I lost my screwdriver bit now. Oh, it's in my drill. I keep forgetting that I just fixed the drill the other day, the battery for it. Oh yeah, the heatsink compound's oozing out. I mean, it's not oozing, but I can see it around the edge of the transistor as I tighten it down. So let me just set my joule to. Yeah, that's good. That's about good. Don't want to over torque screws and damage things. So they're back in now. So I'll just quickly have another look at this and see if I can work out what happened. Where did I go wrong? I mean, the emitters are joined together and the collectors are joined together, but I mean, okay, well I guess when I'm turning one on, no, I'm not turning the other one on. The bases aren't connected together. Is one of these transistors leaky? Oh yeah, they're in parallel. I do silly things sometimes. Yeah, there's nothing there that should make it read different. I wonder if nothing's referenced to ground, so I don't see why, even if the mica was broken and it was shorted, why it would read like that. I'm going to try this again. Yes. You know what? Something was wrong. Either the pins were oxidized, the mica insulator was broken, something was up. I'm actually really happy that I took them out. Well, there you go. That wasn't a waste of time after all. Well, that's good. Alright, moving on. So we've got, well, I'm going to be making up a new board, but oh no, I'm just going to solder wires to it. Yeah, I'm not gonna reuse that plug or the pins. I don't know it's pins, but I couldn't be bothered drilling all the holes through my board and making that up. This will all just get soldered to the board, and any excess wire that I'm left over with, like offcuts, I'm gonna keep everything in here as original as I can. So what I mean by that is, even though, like, so I'm keeping the resistors that are in there, even though I am making a new board for it, I'm going to use the same transistors as much as I can and all that sort of thing. Same bits of wire, same capacitors. I'm trying to keep all the original parts in it, if that makes sense. I just feel they deserve to keep living, albeit a new life, but a similar life. It's still a power supply. You know what I'm saying? It deserves to live on. There's plenty of wire there. That's brilliant. Happy with that. Alright. Now, I'll use this skinnier wire for my base. I think I'll use I'm thinking somewhere in between maybe 4.7 ohms, maybe 3.3 ohms, somewhere around that ballpark. I don't like how that wire is almost touching that screw. Hey! You know what? There's a few things I've noticed in here that were not good. Like, really not good. That screw could have gone through that wire. No screws should be anywhere near wires. That's better. Jeez. Alright. Motorola. Thought back in the day things were done properly. Anyway, I think I'll just put two 3.3 ohm resistors in there. I'll go get them, I'll be back in a minute. I'm just going to use a couple of 2.2s. The reason I'm not too worried, very similar to that power supply rebuilt recently. The transistors are quite spaced apart and horizontally mounted, not on top of each other. So if the heat was going to rise from one to the other, you'd want to do something about the emitter resistance and base resistors a little bit more in terms of increasing the resistance to share the current between the devices, because one's going to try and thermally run away more than the other and conduct more. But in this case, we can get away with low resistances. That's why there's 0.1 ohm resistors on the emitters. Plus it's also a power supply, but anyway. I just got to go do a few things, but I'll be back in about half an hour. For you guys, it'll be a second. Alright, so I've just got some spaghetti tubing for these resistors, because what I'm going to do is I'm going to cut a couple of small lengths, like so. And then sorry. Oh, I didn't lock the picture. Right. And then I'm gonna do the old J hook. One. And the other. You got to solder fast with spaghetti tubing because it melts. Now our base wire. I should have probably put another piece of heat shrink around that. Damn. Yeah, I'll open that back up and do that. Because that is not good the way it is. What the hell? That just stripped one strand out, but it's all soldered together. Craziness. Alright. I'm happy with that. Much happy. And that's my back sorted out. Whoops. Oh, that fits in nicely. I'm very, very happy with that. Okay, so now I can put the back on finally. Because everything else can be done from the front. All we have now at the front is positive, emitter and base, ground and positive and Oh, sorry, negative. Sorry, this is negative to go with the positive over there. I will move that over too, and then we're good to do the backup. Good thing I just noticed that too. Yeah, if I'm gentle, I can fish this out. Beautiful, nice, solid wiring. I mean, it's absolutely solid. It's wonderful. It's multi-core that's been pre-tinned all the way through before it was insulated. So it's just wonderful. Alright. I couldn't be happier with that. I want to try and make it look neat too. Right, so now the next thing I'm going to do, because I'm making up my own board, I'm going to go off and I'm going to cut out the front panel, and I'm also going to clean up my bench. This is what happens when you are basically an engineer and build things. You end up with crap everywhere and you quickly run out of room and have to do routine pack-ups along the way. So I'm going to do a little bit of a clean up, and then I'm going to cut some things into the front panel, and then we'll come back. Alright, I've decided, because this is going to be a 2 or 3 part series video, I've got this all tidied up ready. I've tidied the bench up a little bit. Just what I need is here for now. What we're going to do now is we're going to start. Let me just grab a bowl. This. We're going to start the parts bowl. So protection diode, our Xena diode for the reference, our banana jacks, panel meter. It's going to go off to the side, and we're going to remove off this board everything that we want. Well, I mean, I'm going to remove basically everything except for the resistors. I'll take the power resistor, but I don't know what parts I'm going to actually reuse. Obviously, I'm not going to take the ceramic cap, but you know, I'll take the nice. I don't even know what type of cap that is. I'm just going to take it out of curiosity. I don't know if it's a cap. Anyway, you know, I'll take the poly, I'll take the pot, I'll take all the little transistors. I'm going to reuse that driver, these transistors, on the new board. I'm also going to make the new board so that it mounts the capacitor the same as this. So I'm going to literally take a piece of PCB, trace around the shape of this, put the 2 holes in the same spot and the little slit there that indexes with the case, so that when you put the board in, the slit goes in there, and then the capacitor like that, and my transistor will mount down to there too with the same block. So I've got to measure all that up and reuse all that. So I figured, because all that measuring and cutting the front panel is going to take some time, I'll do that off camera and come back and just show you the finished cuttings and all that. and then we'll get back to designing the PCB. I'll still design the circuit and all that on camera. I'm just not going to waste your time watching me cut holes and cut out the PCB, you know. Alright, we're ready to go. So old, it's got a flathead screw. That's cool. And I'll leave that just for the originality. You see how much easier leaded solder just sucks up? Just making sure it wasn't getting blocked because I haven't cleaned it much lately. One MJE 2955 to be reused. I'm not gonna reuse those little capacitors, these 100 and 200 mic capacitors. You know what? Just for the sake of it, for the sake of keeping it original, I will. That can be the point of this video, to try and reuse as many original parts in the build as possible. Well, truth be told, that was already the goal. So, not that I have a shortage of parts, as you guys know. But I actually have respect for old stuff that was made to last, and you know, if it's still working, I'd like to see it keep working until it doesn't. That's just what I like. Try not to damage the legs on that. These style of capacitors, you can snap the legs off where they're welded to the case quite easily. So I got lucky there. Caught that just in time. That's 500 microfarads, 20 volts. That'll be our output capacitor. We're only going up to 18 volts, so it'll be alright. These solder joints are really, the way they cut it, I don't know what sort of tool they use to cut it. I'll hold it up to the camera because this is actually quite interesting. I mean, there is nothing there. And everything's got this strange, you know? Just had to unlock and lock the picture for that. Sorry about that. Alright, oh, these transistors, I see what do you call it? They're plated through holes and they're flooded all the way through. So the only way we're going to get these out easily is just by flooding them out. So that's fine. There you go, just fall out. That's what I thought. Oh, wrong holes. Not hard at all to get them out. I'll steal the Xena because I go through enough of them. I always find that as many of them as I have, every time I need that specific one, I don't have it. I don't get it. It always happens. Xena really does not want to be had. But I've got other things in plan. Now, whilst I'm going to reuse these, that's just going to go in my spare parts drawer. I'll take that pot for my own personal use, and I'll take that poly resistor, but I won't do that in your time. I shouldn't have even taken that resistor, that Xena diode out on the video. I can just toss this board into my parts harvesting pile and do that in my own time, you know. I just want to take out the parts that I'm going to be reusing in this project. What value is that? 0.022. Can't see myself using that. Not in the build. What are these rated at? 25 volts. 25 volts. They're not going to get used in the build either, so yeah. That's why I want to take off of that. They can just go on the board pile. Probably won't even end up taking anything off of it. Alright, so there's that. The other thing I want to go over quickly is what am I thinking about doing. So nothing complicated. Where the power comes in, we'll have our huge capacitor coming off the bridge rack, you know, and then we'll have a resistor that's biasing the series pass transistor on, or transistors. This will be our output, right? Oh, there's going to be a resistor in here, sorry. And then here, this will go to another NPN transistor, like this. You know, I drew that upside down. Sorry. Let me just think about this. Sorry for the crude drawing. This, okay, we'll have our negative output here. That will come back like this. This emitter will also go to the negative output like so. And then off the positive output, we'll have I've gone blank on the Xena diode symbol. I'm not sure if that's a Xena or if that's something else. I might have gotten this wrong. My apologies if this is confusing you because I've got it wrong. We'll have our Xena diode, and we'll have actually I drew that wrong, sorry. we're going to have the Zener diode down here. My bad. My apologies for all the messiness. And then here we're going to have pot. And this is going to give us basically a reference voltage. I can't think if the Zener goes on top or bottom. I'll work it out later. This is just a crude block diagram. There's, going to be transistors Darlington up driving that. There's going to be base to emitter resistors. There's going to be compensation capacitors. This is just a crude block diagram of how I'm going to make the circuit. And the foldback current limiting, basically at the start of the Darlington stage, we will basically we'll have another transistor whose base to emitter junction is looking across this resistor, and it will pull this node at the start of the Darlingtons, however many there are. It'll pull it to the output, switching this off, and we'll have a pot to set how much it sees of that resistor. It's called foldback current limiting, but that's what I'm going to, the circuit I'm going to design up on the board. So I just wanted to show everyone that so that everyone knows what's happening here. I don't think there's really much more to cover in this video, because I'm going to go off and cut out the front panel now, and then I'm going to sit down and design the board. I've got to remeasure the voltage. I think it was 24 volts available. I can't remember. I've got to take some measurements so I can decide what values of resistor and all that sort of stuff to be used in the circuit. So I got a little bit of work to do. And yes, we're going to reuse this capacitor as I pointed out. So, all right. If you like my content, please like and subscribe, and feel free to comment down below. I'm going to keep working on this, so I'll probably see you later tonight if you're still watching.